All right, all
Okay,
right.
it is 10 p.m. We're recording Achintya and I as RongCast 2.
All
Alright,
right.
it's been a while. Amir and Ryan kind of, we don't know what's going on with RongCast at this point, and it's been like 3 months, alright? And summer's almost over, so we're trying to get this over with. We're trying to fulfill our cast requirement. So here's new RongCast episodes.
All right.
Alright, so what are we doing right now, Achintya?
Right now, we're looking at the physics summer assignment that we have definitely started before.
Mm-hmm.
We looked at this. We're deciding our course of action.
Alright,
Our
so
IA.
the
Mm-hmm.
focus of the summer will be on two parts of your internal assessment IA. Complete the personal engagement piece of your IA and complete the exploration piece of your IA. These two pieces of your IA start off the reader and say your thought process and are pivotal in building your internal assessment and designing one at a high level. Read each attachment given to you with this assignment regarding these key components. Here are some key components. Boring.
All right. Let's get to
So
the interesting part,
it
bro.
seems that it's mainly just thinking about what we want to do. So it's like we're in like the research question phase of it, right?
All right. All right. Uh,
Hmm.
isn't this is not bad. I mean,
What does it
like I
seem
could.
like? Okay. It says complete. Read the chapter rubric of this assignment and understand that you understand what the IB program is reading or seeking when reading and marking your IA. Complete the personal engagement piece of your IA, the expiration point. Okay.
Oh,
So you have to do this part. That doesn't seem so bad.
what? You just you like so the questions on the 45 questions are kind of like ideas for what you could do.
Yeah, so kind of like how they had for like the exhibition, kind of.
Oh,
Let's go through them and see what sounds interesting and what doesn't, and write down the other ones.
all
Let me
right.
grab a pen. I'll be right back. Okay. This
All right.
episode will be dedicated to only physics summer assignments.
All right. All right.
Okay. Number 1. How does temperature affect the spring constant of a spring?
I'm not gonna lie, bro. That sounds kind of boring.
It sounds kind of boring, but it sounds kind of easy, right? Because all you have to
That's
do, because like what we did we did a lot of spring labs last year.
mm-hmm.
Even yeah, so what we did for our labs last year is we found the spring constant of a spring by attaching different weights to it and seeing how the changes in force affect the distance or the displacement from equilibrium of the spring, and using that we can find the constant K value. But I have no idea how temperature will affect it.
Yeah.
Well,
I don't know if it's easy.
we looked it up yesterday and it was like, oh, well, I think increasing heat made a constant higher. Wait, what does it say?
I think cold heat it, heating it up made it easier. I think what's it called? Stretch it because metal expands.
Yeah, as the temperature increases, the spring constant decreases. Hmm,
What?
that's what it
What?
says. Okay, but like, okay. Also, like, you know how like maybe it's different things. You know how like if you like freeze rubber, it becomes
Yeah.
brittle and you can't stretch as much.
Oh,
Does that maybe that does has something to do with it? I don't know. But springs are made out of metal, so it's really not the same. But you know what I'm talking about?
yeah. I get it. I get it.
Yeah, I don't
I
know.
can do that.
How
Next one.
does
Next one.
temperature affect the speed? Actually, you read it. Right, we can go on and
Okay.
off.
Okay. How does the temperature affect the speed of sound in a solid or liquid? That one's not that bad. I don't know what to say. I mean, like, all you got to do is just like go outside when it's really hot. It's really easy. Just go outside when it's really hot and like just like record how long it takes for you like someone to hear you.
No,
Like,
that's in a fluid. That's in the air. This is about like that's a gas. This is about solid and liquid.
oh, okay,
So
that's a
like
little hard.
it's kind of hard. It's like we struggled in like sophomore year trying to find out the speed of sound in just regular air, right, from like across the football field. But I don't know how you would measure it in a solid or liquid. Which like
Oh,
maybe just like a simple
I,
Google search would help that. But like I don't know. That just seems
I
kind of
I remember when you guys did that like sophomore. You guys went to the what's that football field, right? And you just
yeah.
like held.
Yeah, we started like no, we started like had cups and started like making noises and stuff. But it was kind
No.
of like not the best lab experiment that we did because there are so many other noises going on at the same time. All right. and it was like all
Okay.
about it was all about like the human perspective. So like, oh, when do I hear it? Not like we didn't really use any like tools to measure it. So it was all like there's like that definitely a delay and stuff. It was
Okay.
subjective.
All right. All right. In a solid, I don't know how you'd measure that in a solid.
Yeah, I know
Like,
sound travels fastest through a solid. I know that fact, but I don't know why. We never really learned about the speed of sound that much,
eh,
or just
that's
like
just,
we didn't really learn about stuff throughout different what's it called? No, different like objects. Okay, how does a cross-sectional area of a football affect the terminal velocity? That
mm,
seems interesting, right?
yeah, but at the same time, I don't know if it's kind of self-explanatory. I mean, like,
Yeah,
if you
because
have
it's
a
like there you go.
yeah, if you have like a bigger area, right, you're
Hmm.
gonna have more area for air to hit.
Like
So
wind
that means it's slow
resistance.
down more.
Yeah,
Yeah.
and then like that involves like also you have to think about it. I don't know if this is hypothetical or not. We're doing some testing because like that would also involve like having to buy a couple footballs.
Nah, I ain't spending money on this, bro.
And also it's kind of hard to achieve terminal velocity, right?
Oh
Unless
yeah.
you for like what we have, it's like the highest point is like the roof of the school, and you're not gonna try to achieve terminal velocity doing stuff like that, right?
Oh yeah. And what is the cross-sectional area of a football? Like,
Probably from
it's
like
just
where it's point down.
hmm. All right. That's a potential, but
Yeah, it's all about drag force. I don't know.
yeah. All right. Next one. How does the diameter of a string affect the fundamental frequency? Okay, that's easy. That's like
Yeah.
it's a guitar. I can use my guitar.
Mm-hmm.
The thicker the string is, the lower the frequency,
Yeah.
and you can see it. And like the thinner the string, the higher it is. Yeah, that's a really easy one you could do.
Yeah. And that's a personal connection that you can tap. You can do.
All right. I might actually circle
Write
that
that
one.
down. Yeah.
Yeah, write that down. All right. Okay, you read the next one.
Hold on. How does sugar concentration affect the refractive index of water?
Alright.
That seems kind of easy to do, in my
It's
opinion,
easy.
right? Because like refract. Well, that was more stuff we did in ninth and sophomore year, but it seems interesting. Because like all the I forgot what it was called, what the unit was, but it's like the study of light. I forgot. Hold on.
Oh yeah, I remember that. It was
Have to
called
mess around with mirrors and stuff and like optics, but it's optics and stuff. I mean,
Oh
we didn't do any optics last year, but yeah, we did a ton in 10th grade and it was really fun because we're near the end of the year.
I remember doing optics online. All I learned was concave and convex, and that was
Yeah,
it.
and all like drawing all the lines were pretty fun. So actually yeah, I read that down. That's pretty cool. I mean,
You
so
go like
far out of the top five, I think number one seems easy to do. Number five seems easy to do. Right?
I'd say number 4 is the easiest.
Yeah, 1, 4, and 5 seem pretty easy. And then number
Alright,
6,
wait, how does temperature affect the viscosity of fluids?
that seems easy.
Oh yeah, because you take like honey and you heat
Yeah,
it up.
or like syrup and something.
Yeah, something like that. Yeah.
Okay, these aren't
Uh,
all bad.
It's just the experiments themselves are not bad. It's just like actually writing everything down, like all the methodology and stuff.
I mean,
That's
like,
just all nonsense.
the thing is, like, for IAs, it's like you're pretty much asking a question that's already been answered. So you're really
Yeah,
not going to be able to come up with anything interesting or unique unless you, like, solve something for it. That would be crazy.
that's true. That's about to be me, bro.
Yeah.
What?
Here. How does the length of a violin/guitar string affect the sustained time of the violin guitar string after being plucked with a constant force?
Okay, that's easy.
Yeah,
I would
exactly.
just
It's you have
use
yeah.
my guitar. Yeah, and I
Oh,
have a ukulele at home,
yeah,
so
I have one too. My sister broke the string though, so I need to fix it and
yeah.
rewind it. I might show it to you because I don't know how to rewind strings.
Yeah. Oh yeah, you can just give it to me and I'll fix it because I did it on my guitar a million times.
How does
Right.
the temperature affect the range of flight of an elastic band? That's the same thing with like rubber, right? If you freeze rubber, it's
Yeah.
more brittle.
Like,
So
oh,
that's easy, right?
how would you test that though? Like, how would you make it cold? Like, you
You
just have
just
to go.
put it in the freezer for like an hour, or
Okay.
like you freeze it overnight and then test it. But you also have to account for the fact that like just touching it yourself, like your hands, that will provide warmth to it, so you don't know the exact temperature.
Yeah. All right. Next one. How does the temperature affect the internal resistance of a battery? That's a lot of electricity. We
And
didn't
that's
do
kind of
electricity
potentially
here.
hazardous too, right?
Yeah, we didn't do anything with electricity last year, right?
No, I mean
Did you guys 10th grade?
yeah, we did fundamental like just like current amperage and or current resistance and voltage, which is pretty
Mhm.
easy, and like all like the series and parallel circuits, but nothing like too out of the ordinary, just basic low level stuff.
Yeah, if you like heat up a battery, I don't know how all
Mm-hmm.
that's gonna go. Mm, all
How
right,
does the
that's
ang Yeah, I mean it's not that bad of a question. It just seems weird.
yeah.
How does the angle of rotor blades affect the lift force of a toy helicopter?
Okay, that could kind of be fun, but like
You have
you
to
just
like
use the buy a helicopter. I mean,
and you have to make more than one, or at least change the angle of the rotor blades. All
yeah,
right.
that's
I mean, okay,
kind of
if you made it out of like no, because that would work. Because you need like an E3 thing, whatever it's called. It's like you can make it out of Legos, but then like the motors wouldn't be able to work because like Lego helicopters can't fly on themselves.
that's true. I mean,
Maybe.
you can use like Boo Whiz. What is it called?
Yeah.
I don't know, something like that. You can definitely
I,
try and do the helicopter, but
you
you just
can
need a
do
lot
it.
of
It just seems like yeah, too much work. All
yeah,
right.
it's a lot of money too. All
Yeah,
right.
all the stuff of like electric motors and stuff don't really seem that possible for like what we have to do, right? Toy helicopter, like number 11, efficiency of an electric motor, efficiency of a transformer, um, magnetic field strength of magnets affect the efficiency of electric motor. Like no
I
one's
don't know
gonna pick
how.
that one, right?
Yeah, we can't do
Like
that.
that.
We cannot do that.
No. What the hell? I was like, okay, number 14. How does temperature? A lot of this is just how does the number of something or how does the temperature of something affect something else, right? So I was like, bro,
Mm.
what is this? What it's a young modulus.
Young modulus. Oh,
It sounds
it's like
familiar. I just don't know what it.
yeah, the young modulus. I think we learned that either in chemistry or in calc. I don't know how.
Oh, it's the ratio of
Modulus.
tensile stress to tensile strain.
Oh yeah. The string stuff. Okay, that makes sense.
I mean, it was.
Wait, how?
I think it was. I think it was mentioned, never explored.
Uh,
Stress is the
um,
amount of force applied per unit area, and strain is extension per unit length. What?
mm, I
What was
don't
it? Wait,
know.
yeah. See, all it's just the temperature of a wire. It's like yeah, it's like all temperature about like rubber or if it's something being stretched. So a lot of it's just temperature and tension.
Mm-hmm.
And
All right. So how does the concentration of salt and water affect the specific heart capacity? I think it just means heat.
yeah,
All right.
that one doesn't seem that bad. Yeah, that's just you just boiling stuff.
All right.
All right,
Cross-sectional
so
area.
that's actually pretty easy to do. You can do it at home or
Wait.
like
Well,
or in the chem
the
lab.
salt one.
Yeah, the
Yeah.
specific heat capacity because that's just like when like specific heat, just like how much it takes to boil, right? I don't
Oh
remember.
yeah.
I don't think I can.
Yeah, how much energy you can absorb
No,
before it's changing.
the amount of heat needed to raise the temperature of 1 gram of substance 1 degree Celsius. So how?
Yeah.
Yeah, so
So
yeah, that's just not bad. That seems pretty fun to do. You just have to
all
make
right.
sure you don't burn yourself.
All right. Next one. How does the cross-sectional area of a sail on a toy boat affect the initial acceleration? Okay, that's easy.
Yeah, that one
You
actually
gotta.
seems better to do than the toy helicopter because you're not flying anything.
Yeah, it's just like the bigger the sail, the
Mm-hmm.
more wind you'll catch. Therefore, you'll get.
Yeah.
Wait. Well, how does it affect initial acceleration? I mean, like not like average acceleration, but like initial, like when it
I
first
guess
starts.
that just means like you have to like have an air current that's like the same force at and like you have to see like how because this is just like okay yeah, it's like if as yeah it's like you said like the greater area for wind resistance and stuff to be able to push it right, and stuff but like
Hmm?
I guess that just means you have to have like a constant force source like an air current to push it and you just test the cross sectional area so if you get like a fan and just like hold
Yeah.
it against the boat so that's probably what you have to do and
Yeah,
then
it is.
yeah,
Yeah.
initial acceleration, and then you just have to use like kinematics formulas to solve it and stuff. So that doesn't seem that bad.
All right. All
And
right.
there's a lot of factors you have to account for. It's like you have to use the exact same boat, just like change the sail, which like yeah, or you make
Yeah.
several boats, like several base bodies, and then like change the sails.
Wait,
But
no. I think no. You'd have to change the sail because like
no, I'm saying like you get you make a boat base body right. have like
Right.
have two sails for each boat that you make. One that's like bigger and that's like of proportional sizes or something, or same sizes.
Uh,
And then see like
I
if it changes both for all boats. I don't know. Yeah,
I
there's too many factors. You don't want to like change it at all. Keep it constant.
I have like Lego boats that like
Yeah.
float and
Mhm.
like those sets, like the Coast Guard sets.
Yeah.
Yo, I could use that.
You can just get like a carve a boat, or like get a
Oh,
plastic boat or something. Like
that's
one that's
true. That's
made for testing.
all right. Good
How does
pencil.
a temperature affect the restitution of a bouncing ball?
I think that's just how much it can bounce back.
Yeah.
Restitution. Oh yeah, it's just gonna be like the same rubber thing. Like if it's cold, then it probably won't bounce as much. Wait,
Yeah, it's just
searching.
about like when two objects collide, the speeds of their collision depend on what they made of. Wait, so it's like just like the speed of which it bounces back.
Yeah.
It's the coefficient of restitution is a ratio of the final to initial relative speed between two objects after they collide. Yeah, it's just basically how fast it bounces back. Which again, bouncing balls are made out of rubber, right? So if you drop a frozen
Yeah.
bouncing ball, it's not gonna bounce it that much.
That's true. That's a easy one.
Yeah. How does a cross-sectional area of a card attached to a vibrating mass affect the displacement of the mass after 20 oscillations?
Huh?
That seems weird. Because okay, first you have to have something that like constantly vibrates it, right? So, that's gonna be hard to achieve. Like vibrating at a constant rate. And this is just about like cross-sectional. So you add. That's assuming like the card adds like another form of resistance. That's weird.
Wait, so the card attached to a vibrating thing. So how much does the vibrating thing move after 20 oscillations? I don't know how
due to the cards like being attached to it.
I don't know what that would do. I mean,
that's weird. That's weird.
Okay, yeah, I'm not doing that one.
How does the radius of a football affect the impulse of the football when kicked?
Oh, like the initial, like the momentum impulse is like what?
Shoot.
Momentum.
Impulse is just force times time, right? Wait, is it? Yeah.
Hold up.
We passed the exam. That's all that matters.
Okay, impulse equation. Yeah.
Force times time. Yeah.
Alright, impulse is momentum. Alright. How does the radius affect the change in momentum on the ball? I mean, if you have a bigger radius, I mean, like
the force. If you have like a smaller radius, you have like a greater force attached to like a singular point, right?
Yeah, and if you have a bigger radius, you have like less concentrated.
It's more spread out.
Alright. Okay.
How does the mass that's added to an inflated balloon affect the terminal velocity of the falling balloon?
Bro, it's just gonna make it larger. Like, you just add mass to a balloon. It's gonna drop faster. You just have to combine terminal velocity.
Mm-hmm.
That's easy. You just got to drop stuff.
Yeah, and dropping stuff kind of sucks.
How does the width of rotor blades on a paper helicopter affect the terminal velocity of a paper helicopter? Paper helicopter.
How do you even make a paper helicopter?
I mean, it's like, you know those helicopter flowers?
Yeah.
Yeah, I think it's like that.
It's like, yeah, I see it. It's like you fold it and it just falls down. But
that would be easy.
Yeah, the only problem with that is that you have to make sure that like the rest of the paper, the rest of the body is the same. You just the way you fold it is that only the rotor blades are different. So that means just like because like that means it's just weird. There's so many things you have to keep constant, or at least talk about this or discuss when talking about something. All right.
Are we? IAs you do by yourself, right?
Yeah, it's internal, so it's an individual thing.
All right. So, how does the paddle area of a water wheel affect the efficiency of the water wheel converting to electrical energy? That's easy.
But you're not really doing that, performing it. Because for IAs, are you actually testing it, or is it all hypothetical? Because like, I think you just can't test, but some of these you can.
Oh, I mean, like all the chem kids, right? They come in to do their IA, like actually the experiment for some of them.
Yeah, but physics is different though.
Something you can test.
Yeah, but still, 22 is easy to talk about, but you really can't it's like because that involve like actual like having to transform. It's like actual like what's it called, turbines. Like maybe you can make a simple turbine and stuff, but like it's a lot of work.
Like you could just like make like a just like a perpetual not perpetual motion, but like
Yeah,
just
you're gonna
have
make
water down,
yeah.
push the thing, and then have it generate a light,
Mm-hmm.
like
You put it in
generate
like a
like
bucket or something.
something like that. I mean, yeah, you could do that.
It's possible. It just takes a lot of work.
All right. How does the angle of initial release of a pendulum affect the subsequent calculation of g from the pendulum? That's just a lot of math.
Yeah, that's pretty much all math.
The angle of initial release. I mean, yeah, if you have like, wait, g as in
Wait,
effective.
the gravitational constant, huh?
I don't know. Gravity is affected here. Affect the subsequent calculation of g from the pendulum.
Eh,
That's too much math, bro. I ain't going back to
yeah.
AP physics.
How does the temperature of water in a wine glass affect the resonant frequency of sound produced when the wine glass is struck and the rims begin to freely vibrate? So this is another temperature one. That means like that's like, that's like how like people can play instruments using like glass or like actual like crystal glasses and stuff. That's something like that.
Yeah.
Or it's all like all about sonar things, which seems interesting to do. But you just have to make sure it's like.
I mean, it's like
Yeah, it doesn't seem that bad.
it's fairly simple. Yeah.
But when the wine glass is struck, yeah, so that means kind of interesting. I don't. Only hard part would be how to calculate the resonant frequency of sound.
Oh, that's true.
Because you have to like measure it. I mean, like you can try and find like a device that does that.
Oh yeah, you can definitely. Okay. How does the volume of water in a wine glass affect the resonant frequency of sound produced? The volume of water?
It's pretty much the same question. Right?
Yeah, it's just changing how much water is in the thing.
Mm-hmm.
All right. How does the temperature of grease affect the depth of crater created when a mass is dropped from a known height?
But what do you apply the grease to?
No, I think it's just grease. You just have grease, and you drop something in the grease.
Yeah, is it on the grease or is it on the Okay. Because I didn't know that you apply the grease to the mass and then drop it onto something, but you drop it onto the grease.
I thought you'd like put the grease on something and then drop the thing.
Yeah,
drop a mass.
That's what I was thinking. But what would grease really do? Would it like
lessen the depth of the crater? Cause it's kind of like adding like memory foam.
Maybe.
Like.
Well, it depends on like what type of grease you use. Because if you use like. That's weird. Okay, that's an interesting one.
Where'd you get the grease from? Kind of niche.
Because you can like make cooking grease or like motor grease. There's a ton of greases that you can use, or just like grease for your hair.
Bruh. Okay.
How does the distance between panes of glass and double glazing affect the rate of heat loss? What?
Oh, okay, yeah, I know this one.
Yeah,
so like, yeah, double glazing is like just a type of like putting glass together, and like basically if you have more distance between the glass, like supposedly you'll have less heat loss.
Yeah. I know what you're talking about.
Like, it's just how if you have a pane of glass, but the glass is like farther away from each other.
It's about like the light going through the glass and make it like cooler.
Yeah, it like refracts weird or something.
How does the number of panes of glass affect the rate of heat loss? That's a similar one.
Same. Okay.
I mean, that would kind of be hard to do, right? Because you have to do that in like a room that's like kind of empty, that only has one window, and that involves making multiple panes of glass.
I don't know how you're gonna get like quadruple glazed glass. That's like you could do that. You could just buy it off from Home Depot.
Mm-hmm. Oh, okay. Number 30. Skipping 29. How does the cross-sectional area of the pipe in a siphon affect the volumetric and flow rate of the water in the siphon?
Yeah, that's easy.
Yeah. And then 30. How does the height of a ramp affect the time taken for a cylinder to roll down the ramp? That seems perfect to do. That seems like the easiest one to do, bro.
It seems like the easiest one, but it easily turns into the hardest one because like inconsistent like measurement.
Oh yeah, and there's like the ramp is slightly angled, right? So it's like it's angled to the side, so like that just seems like at face value seems like the easiest one to do.
Easiest one, but it's also the one where the things can go most wrong. So
yeah, that's how we do it. That's why it's called RongCast. Oh
Oh,
my god.
we said the name, bro.
hmm How does the
Alright,
distance between two tower How does the distance between two towers sustaining a flat metallic bar affect the vertical depression slash sag produced when a known mass is added?
Wait, what? Read that again.
How
What
does
is
the
this?
distance between two towers sustaining a flat metallic bar affect the vertical depression slash sag produced when a known mass is added?
Oh,
So
okay,
that, yeah,
that's just
not just saying that's like you're holding a bar on top of two things. How far it's like it's saying like where the center of mass is and like where the other parts of the like the it's like it's also talking about I think it's the tensile forces within the bar and like yeah. So when
this is just
you're adding a mass as something at different that has like a metal bar that's like different levels of like tensile like forces attached to it, right?
all right. All
I
right,
think
yeah,
that's
it's
what
just
it's asking about.
how much it like just bends when you
Yeah.
add. Yeah.
So like
All right.
how much does it bend when you change the like how much is being stretched? I think.
Yeah. All right. How does the breadth of a flat bridge affect the vertical depression slash sag produced on a mountain? That's the same thing. It's just
Pretty
like
much the
how
same.
wide.
Yeah, yeah.
Right. How is the time period of oscillation of a solid sphere on a curved track affected by the radius of the solid sphere?
Wait, hold on. Sorry. The
So if a
time.
sphere goes around a track,
Mm-hmm.
if you have just a bigger sphere going around a track. I mean, if it's the same mass and you just change the radius, you just lower the density. So like theoretically, you shouldn't really do anything. I mean, actually, no. Actually, having a bigger radius
For like air
would mean
resistance.
air resistance and stuff. You just be slower. All right.
How does
Period.
temperature affect? Oh, sorry. How does temperature affect the magnetic field strength of a permanent magnet?
Of a
Um,
permanent magnet. What's a
that might be a
permanent
little
magnet?
hard to do because
Wait,
like
what's a permanent
I don't.
magnet?
Yeah, it might be hard for us because we don't know what a permanent magnet is. I'm
All
assuming it's a
right.
magnet that just doesn't lose its. And it always has its. Yeah, that's always on. Okay, so it's
Like,
just
yeah,
like the regular magnet that you always find. The electromagnet you can turn on and off.
all right. How does temperature affect? I don't know. That yeah, that's kind of weird. I
Yeah.
don't know how you test that. Like,
Okay, because
if you
first of all, how would you heat it up, right? You're not putting it in the microwave. You have to get like a blowtorch or something. I guess
uh,
like you can just keep at room temperature and just not add heat. You just cool it down.
yeah, you just put it in like the freezer and take it out and just put it
Yeah,
next to some iron filings and see how
that's
many
actually
filings.
that's actually not that bad though.
Mm,
You're not gonna count individual filings though. You're trying to like another way to
oh
test
yeah,
the field
it's like
strength.
nails, just
Yeah,
like
yeah.
clips.
You're not gonna count
No,
microscopic
no.
nail iron filings.
Okay. Besides that, just use like paper clips or something and like cool it down or blowtorch
Oh,
it.
look at number 35.
How does the mass of dust covering a solar panel affect the efficiency of the solar panel? Nah.
Yeah, yeah. It's like okay, I'm like, hey
No,
mom, let me go to the roof really quick and pour a ton of sand all over it and just see what
you guys have
happens.
you guys have solar panels?
Yeah,
Yo, okay, I know where I'm going for this one, bro.
yeah. It's like, hey mom, it's like the reason why it's like to because it's like more efficient, like lowers the energy bill, right? It's like, hey mom,
hmm
let me increase the energy bill for my science experiment.
Let me put some dust on it, bro. A little bit. Oh, let me cover. Yeah, I mean,
It's
you
like
definitely
okay,
know what happened.
at face value, right? Of course, if you have a more massive specks of dust, right, it's gonna lower
Mm-hmm.
the overall efficiency of the solar panel. That's just like common sense, right?
Mm-hmm.
But like,
Uh,
I mean, like at face value, right?
true. I mean, you don't know. Maybe the dust could be.
Yeah,
Maybe
maybe.
dust could help it, bro.
And
Maybe
like,
we've been doing.
yeah, if the dust like blocks it, it just makes all the light just go onto one specific spot. So that part of the spot is really efficient.
Bro, that's what we need to do. We need
Exactly.
to, bro. All right.
You
How
make
does
a
the math?
funnel out of the dust, a light funnel.
This is so stupid, bro. Stupidest idea ever, bro. Let's let's not use the rest of the solar panel. Only use
Yeah.
like
It's just,
one
like just
pixel.
burn a hole into the solar panel because all the light is concentrated on that specific point.
Yeah, we're fishing my ass, bro.
How does the mass of a block affect its recoil distance after being impacted by a constant external force? That's not bad. That just collisions and
Yeah,
momentum.
this. All you have to do is just like shoot something that's
That's
heavy.
literally just momentum.
Remember
Okay.
that ballistic cannon? that Mr. Lay has in his office.
That one. Yeah, that's what you'd use for it.
Yeah, that's what I did for like our Goldberg
Mm-hmm.
Gold
The Rube
thing.
Goldberg.
It didn't work, but like
No,
whatever. But, like,
ours did.
whatever, bro. It still
How
got
is
like an A.
how is a slit spacing produced from a laser depend? Yeah, oh, yeah. We're not doing this. I'm not even going to read the rest of it. Dependent on
Slits.
the distance from the screen. What?
What? Wait, a slit spacing produced from a laser, dependent on the distance from this. Whoa. Oh wait, is it if the laser's close to it? I mean, how is the slit spacing produced from a laser dependent?
I don't even know. This is about diffraction. Young's double slit passes
But-
light of a wavelength 65 nanometers passes through two narrow slits. What?
Yeah,
This is
no.
it's all about like refraction and stuff.
Yeah.
We don't know this. We don't know this.
Just not do this one, man.
yeah.
This is
Yeah.
good.
Second,
Alright,
I just saw laser. I said I don't want to do it.
Alright, how does the temperature of a rubber affect the coefficient of static friction between the rubber and okay, that's easy,
Yeah.
bro.
It just rubbers already has a ton of friction between. Let's like try dragging an eraser over like a rough surface.
39 I could do. Like, how does the temperature of a guitar string affect the frequency produced when plucked at a constant force? Yeah, because if oh, okay. So
Put
I
the
learned this.
guitar in the freezer.
I learned this the hard way, bro. Like, heat can warp your wood
Mm-hmm.
so that your guitar eventually becomes like unusable because of the sound quality. The string can be fine, but the wood itself will just like warp apparently because
But
of
then you have to
humidity.
but then you have to make sure that the string is only affected, not the rest of the wood.
Yeah, that's what happened to my first guitar. I think I left it outside on the patio and then it just died.
What type of? It was a wooden one.
Yeah, that's the one. I got a new one from like Costco. That's like part of their deal.
No.
It was not as good as my old one, but whatever. I ain't paying that much money, bro. Guitars can get expensive really fast,
Mhm.
bro. Alright. How does the density of a liquid affect the angle subtended by the diffractive waves when the liquid is passed through a single slit in a ripple tank?
That's another one. Is like number 37. We have what is it? What is it, even a slit, bro? We have no idea what that means.
Bro, what's a ripple tank, bro?
Yeah.
Okay.
Then just ask more questions that we know how to answer.
Okay. How does the radius of a copper pipe affect the time taken for a magnet to drop through it?
That's kind of interesting.
I mean, if you increase the radius, then like there's more
Yeah.
distance.
The magnet's
Magnetic.
not gonna fall down.
Yeah. Yeah. Okay.
It just depends on how big the magnet is too.
Mm-hmm.
How does the
Okay.
resistivity of a metal pipe affect the time taken for a magnet to drop through it? Kind of similar, but it just specifies that it's just metal. But
Yeah, that would be hard to measure the resistivity
yeah,
of a metal pipe.
What even? Yeah,
How resistive it is.
yeah.
Oh, what?
It's just weird.
Okay.
All right. Number 43 is just like one we had earlier. All right, temperature
How does
affecting
temperature-
viscosity. Yeah, it's just like number 6. So it's like
Oh, yeah.
well,
Okay.
this is just specifically castor oil.
I never actually knew what castor oil was.
Okay, number 44. How the temperature of a lubricant applied to the bottom of a solid affects the coefficient of dynamic friction when the solid is pulled along the surface.
Okay. I mean, if you have a
Okay.
cold, then like technically it would be like sliding ice,
Mhm.
and if you have like a hot lubricant, then it's like more friction because of the heat,
Yeah, or it just evaporates.
something like that.
How does the diameter of coil on a battery copper coil train affect the speed of train? Oh my gosh, this involves electromagnets and stuff.
Wait, of a battery copper coil chain?
Yeah.
Okay, never mind.
Yeah, we're not doing
Never.
this. Some of these, okay. Well, it's a 34 minutes so far in the recording. All right.
All right.
This doesn't seem bad. We can easily just pick one of these because these are just ideas. We can come up with our own. I'm probably just gonna pick one of these and just stick with it. All right.
How are they? Guitar one.
Yeah, you do.
Yeah, it's
all
gonna
the guitar ones, but like
Yeah.
these don't seem that bad. And it's also great that because originally you made me believe that we had to answer all these individually, but no, those are just ideas. Because if we had to answer all of these, it's like bro, it's like
Yeah.
we do it August 9th, the day before school starts. Like bro, were messed up.
Yeah, okay. My bad. My bad.
It's like answering. It's like you miss a TOK lesson, and then you answer all those like extended essay or not extended essay, the TOK exhibition answers by yourself.
Bro, that's just stupid. I hate stupid. I actually love TOK. I
I
love
love
TOK.
TOK. I love creativity,
I
activity, and
love
service. Okay.
cats. I love TOK.
Yeah. Okay. And that's the end of the episode. Thank you. Goodbye. Say goodbye, Achintya.
All right. Bye, Miss Milton. We love
Bye.
you, bro. We love you.
Yeah. Shout out Rong Restaurant. All right. Bye.